Hi, I'm Julius, and let's talk about the 4 different metric types in Prometheus. Gauges, counters, summaries, and histograms. Each of those types you would use in different situations, and there's things you have to know when using them in your applications and also when querying them with PromQL. So let's have a look at each type, what it means, and what you need to know to use it correctly. Okay, let's start with the simplest of the 4 metric types, which is the gauge metric. Gauges are just metrics that can naturally go up or down because they represent a current measurement or a current count of some sort, like memory usage, a queue length, disk space, or temperature. Usually for gauges, you're really just measuring some numeric value that already exists somewhere else in your program or in the real world, and you just want to expose that value as a Prometheus metric. So when you add a gauge to your application, the instrumentation client libraries give you a couple of methods to update its value. First, the set method allows you to set the gauge to any arbitrary value, but there's also methods that allow you to increase or decrease the current value in a relative way, either by 1 or by a given amount. Now the cool thing is that the like and subscribe buttons below this video also have an inc method that you can call by simply pressing them. So I'd be super thankful if you want to do that to help this channel. Okay, and some client libraries even have helper methods to store the current time as a Unix timestamp in a gauge. And that can be useful if you want to expose the last time that some event has happened, like a boot time, a process start time, or the last run of a batch job. In the metrics exposition format, a gauge just shows up as a single time series like this, at least if you don't split it up by any additional labels. And when it comes to querying gauges in PromQL, there's not much you have to know. The current value of a gauge is already meaningful by itself, so you can often just graph it as it is. And of course, that doesn't mean that you can't apply all kinds of aggregations or other operations to it when you need to. For example, for gauges that contain timestamps, you may want to subtract them from the current timestamp, which you can get using the time PromQL function to figure out how long ago an event has happened. Okay, on to counters. Counters are a bit more interesting. A counter represents a cumulative count over time, like the total number of HTTP requests that your app has handled so far, or the total duration in seconds that it has spent in handling those requests. And unlike gauges, counters are only ever allowed to go up over time and never down. The only exception to this is when the process that's tracking and exposing the counter crashes or restarts for some reason. And in that case, the counter value always has to restart at 0. That's called a counter reset, and we can deal with those gracefully in PromQL. Now, in instrumentation, counter metrics only have 2 methods to update their value. The inc method allows you to increment the value by 1, and you would usually do that when you've just handled a request or some other type of countable event in your application, and you just want to record that it happened. Now, sometimes you also want to increment counters by fractional values or even by integer values larger than 1. For example, if you wanted to track the number of seconds spent handling requests, that would usually be some fractional number of seconds. Or if you just handled an entire batch of requests at once, maybe you want to count all those requests in one go as well. For that, counters also have an add method that allows you to increment the value by an arbitrary amount. And importantly, counters do not have any method to either decrease the current value or to set an absolute value, because that just conceptually doesn't make sense for counters. In the exposition format, counters look exactly like gauges, except that the optional metadata indicates that the type of the metric is a counter. Coming to PromQL again, you'll almost never want to look at the absolute value of a counter. If you think about it, counters are just cumulative counts over some arbitrary amount of time that totally depends on when the counter started from 0. So that may be a year ago, but it also may just be a minute ago, and the absolute value doesn't tell you anything useful at all. So what you really want to know instead is how fast the counter is going up, averaged or smoothed over some window of time. So for example, to find out how many requests per second you're getting. For that, PromQL gives you the rate, irate, and increase functions, and you will always want to wrap one of those functions around a counter before doing anything else with it. By the way, all those functions can deal gracefully with counter resets, basically by treating any decrease in the metric value under the provided averaging window as a reset and correcting for that as much as possible. Okay, on to summaries. Summaries are useful if you want to track the distribution of request latencies or of some other set of numeric values as a percentile or a quantile, as we like to call it in Prometheus. When you first create a summary in your instrumentation, you can specify which quantiles you want to calculate along with the error margins. And then whenever you want to track a specific value, you call the observe method on the summary object with that value. So, for example, if you just handled an HTTP request that took 2.3 seconds, you would call the observe method with a value of 2.3 to record that duration. And the summary metric object will automatically update the output quantiles based on a streaming algorithm. In Exposition, summaries are expanded into a set of time series, one for each computed target quantile, as well as the total number or count of observations and the total sum of observations. So in the case of request latencies, the _count time series represents the total number of requests you've handled, and the _sum time series is the total time you've spent handling those requests. You can actually see the output of a summary as a collection of gauge and counter metrics. So in PromQL, you can just use the individual series like counters and gauges. Just please don't try to average or otherwise aggregate quantiles from multiple service instances or other label dimensions, because there's just no statistically valid way to average over percentiles. For example, if you had the 90th percentile latency from 10 different service instances, there's just no way how you can compute the overall 90th percentile latency across all the instances. That's why you typically only see summaries for distributions where you don't care about aggregating across dimensions. If you do need to aggregate, then you'll need to use histograms instead. So let's talk about histograms. In a way, they're similar to summaries in that they allow you to track the distribution of a set of numeric values, but instead of outputting pre-computed quantiles, a histogram counts the input value into a set of ranged buckets to give you an idea of how many values you've seen for each range category. So, for example, how many fast or slow or still reasonable requests you've had. And one specific thing about histograms in Prometheus is that they are cumulative histograms, meaning that each bucket also contains the counts of the previous lower ranged buckets, so that the normal non-cumulative histogram you can see here would look like this as a cumulative one. The benefit of a cumulative histogram is that we only need to define the upper boundary of each bucket range, since each bucket implicitly starts at 0. And we'll see how that upper bucket boundary is encoded as an LE or less than or equal label in the time series that make up the histogram. When you create a histogram in your instrumentation, you have to provide a set of bucket ranges to the constructor, and then you can observe values like request durations into the histogram, just like you would have done with a summary. Now, the histogram then automatically takes care of incrementing the right bucket counters for you. In the exposition format, each histogram bucket is exposed as a single counter time series with an LE label indicating the upper value boundary of that bucket. LE just means less than or equal, so for a bucket with an LE label of 0.2, that would mean that it counts all requests that took less than or equal to 0.2 seconds. And you also get the sum and the count of all observed values again, just like in a summary. Now, since each bucket generates one output time series, the main trade-off you have to make when choosing the number of buckets and their ranges is between cost and resolution. The more fine-grained you make your histogram buckets, the better the resolution of the histogram is going to be. But at the same time, if you go for too many buckets, you might blow up your Prometheus server. So if you want to learn more about those trade-offs and strategies for choosing buckets, check out this Prometheus docs page, which I'll also link down in the description. So, on to PromQL. You can see a histogram as a set of counters and query each one of them individually, but the most common thing you will want to do is to calculate approximated percentiles from the histogram. You can do that using the histogram quantile function, which is the only function in PromQL that actually looks at and understands the meaning of those LE bucket boundary labels. And since the buckets are counters, you'll almost always want to wrap either the rate or the increase function around the histogram bucket before passing them into histogram quantile. That way, you constrain the input histogram to only the events that have happened within a known and recent time range, rather than some arbitrarily long time range from whenever your application last restarted. And histograms also allow you to aggregate between instances or other label dimensions using the sum operator. Just always be sure to preserve the special LE label in aggregation so that you still end up passing a valid histogram into the histogram quantile function. By the way, since both histograms and summaries give you the total sum and the count of your observations, you can also use both metric types to calculate the average request latency even without any buckets or quantiles. That's not as good as knowing the distribution, but it's cheap and can come in handy at times. Okay, one last important thing. There's a new native histogram type in town that's coming to Prometheus soon. It's already implemented in an experimental way, but a lot of things around it are still being tied down, so it's not quite official yet, and I won't dive deeply into it right now. But those native histograms will not only be different from the histograms I just described, but even totally different from all the other metric types in that they will allow you to store an entire histogram in an efficient way in a single sample of a time series. Let me know if you'd like me to make a video about that once it's fully out. Alright, that's it for metric types. If you want to learn more about Prometheus right now, check out my training courses at training.promlabs.com, and please also like and subscribe down below if you want to see more Prometheus videos in the future. See you next time.